Good morning student friends. In this lecture today we will see common important defects occurring in the casting process. In the first chapter only, while studying the introduction, I told you that there are three defects in the casting process. Means defects are categorized into three major groups, that is major defect, intermediate defect and minor defect. Major defects means if that defect has occurred in the casting process, then that casting is susceptible for scrap. Means chances of making that casting as a scrap will be more. That is major defect. Means major defect does not have any kind of repair. Second defect, that is intermediate defect. Cost involved in the repair of that defect is more, but we can save that casting from becoming a scrap. We can save that casting from becoming a scrap. That defect is called as an intermediate defect. And minor defect means with the minor corrections we can use that casting in the practical applications. That defects are called as a minor defects. Now one by one we will see the defects, its appearance and causes of defects, and which are the different remedies that has been suggested for the defects we will see. First is the blowholes. Presence of air or gas bubble in the casting is called as a blowholes. Casting has a blowholes on its surface or inside the surface, and that defect is occurring because of low porosity of the mold. Means we have seen the gases are developed inside the mold cavity. The development of gas in the mold cavity has different sources. First source is itself molten metal. Molten metal has a sulfur oxide, nitrogen oxides. Again, when molten metal comes in contact with the molding sand, water particles in that molding sand are converted into water vapors. That is again a gas. Again, few organic matter is present inside the molding sand, and in a contact with molten metal, that organic matter is going to burn, and that organic matter also creates a fumes or gases, and if that gases are not escaped to the environment due to low porosity, that defect is occurring. Second is partial flow of molten metal through the gating system. Utmost possible we have to take care that the gating system must be full of molten metal, and it is possible in case of pressurized gating system, and it is not possible in case of unpressurized gating system. In case of pressurized gating system, we are applying external pressure on the molten metal which is more than the atmospheric pressure. That's why there is no presence of vacuum inside the gating system, so there will not be no entrapment of the air. That is, partial flow of molten metal takes place in case of unpressurized gating system, and it is not possible in case of pressurized gating system. The design of the gating system should be such that it must not take the outside air into the gating system. Likewise, you have to design the gating system. Presence of air or gas bubble in the casting is called as blowholes, and causes of blowholes are porosity, low porosity in the mold, and partial flow of molten metal through the gating system. For escaping of air, we are using the good porosity of the molding sand. Second, vents we are using. We have seen in the basic terms, vents are the small opening provided to the mold cavity through which air or gases are escaped to the environment. Again, we are using open riser for escaping of air, but by using all those things also, certain amount of porosity is created inside the casting. It is because of it has a low porosity, or it has a low permeability. Second is inclusion. Presence of sand particles inside the casting, that defect is called as inclusion, formed when uses of loose sand molds. Now I told you removal of the pattern from the rammed molding sand plays a very important role to avoid this kind of defect. Now while removing the pattern, if we are making a so much hurry, then mold cavity is damaging at the sharp corners and loose sand is created, and that molder, if that molder will not remove that loose sand from that mold cavity, then it is dispersing inside the molten metal, and this inclusion defect is liable to occur. Now for that purpose, we have seen in case of draft allowance, the surfaces which are perpendicular to the parting line are made inclined to that parting line, because removal of the pattern must be a easier task. Again, that shake or wrapping allowance is also given to the surface of pattern for its easy removal. So removal of the pattern is very important. Skill is required while removing the pattern, and utmost care we have to take that there should not be a formation of a single loose sand of that particle. Otherwise this inclusion defect will come in the casting, and which is need to be removed or repaired. Next is dross. Presence of foreign particles or impurities inside the casting is called as a dross, formed because of improper separation of the impurities. We have seen in case of cupola furnace we are pouring the charge, and that charge consists of coke, flux and metal. After burning, that flux is converted into slag, and it floats on the surface of molten metal because slag has a lower density. So presence of slag inside the casting is called as a dross, or any kind of impurities which is a foreign impurities, means which is not part of the molding process. So separation of the impurities from the molten metal is also very important. We have to separate the impurities while taking metal into the ladle. Again, while pouring the metal from ladle into the pouring basin, also you can go for separation of impurities from the top surface of molten metal to avoid this defect, that is a dross. Second is misran. Non-filling of molten metal to the farthest point of the casting is called misran. Suppose casting has a very longer length, and that metal is not reaching to the farthest point, means pouring basin is at one corner at one point, and that casting has a length of 1 meter, then that metal will not reach to that farthest point, and at an intermediate point that metal is going to solidify. That defect is called as a misran. Non-filling of molten metal to the farthest point of the casting is called a misran, and that defect has been shown here in the figure, that you can see here pouring basin or getting system has 1 point, and casting has longer length, and before coming to the last point of that mold cavity, somewhere at intermediate point the metal has been solidified, and that defect is called as a misran. Swell means it refers to the condition of enlargement of the mold cavity when molten metal is poured into the mold. Now suppose swelling means आपण मराठीत त्याला म्हणतो सुजणे. The mold cavity becomes a bulkier. That defect is called as a swell. It refers to the condition of enlargement of the mold cavity, and it is caused either by insufficient ramming or pouring the metal too rapidly. Now suppose as per practice we have to ram the molding sand for 3 times, and if that molder has made some laziness and he has rammed that molding sand only for 1 or 2 times, then that ramming is not proper ramming, means cohesive bond has not been formed between the two sand particles of that mold cavity. At that time high pressure, high temperature zone is created inside the mold cavity, and if that ramming is not proper, slightly the mold cavity enlarges, and that defect is called as a swelling. And as and when mold cavity enlarges, the size of the casting will also change. Rapid pouring of molten metal in the mold which is not properly rammed, that is the cause of this defect, that is swelling. Next one is the shrinkage. It refers to the condition of the casting resulting from concentrated contraction of the metal during the solidification, caused by improper location of the gates and risers. Now very important thing, shrinkage. We have seen that shrinkage defect is minimized by providing a riser at a suitable location as well as gates at suitable location. Suppose if casting is having more size, 3 to 6 gates are also required to the gating system, and if only one gate is present which is having a small cross section, and by using that gate if we are trying to fill the mold cavity which is having a large cross section, then that defect will come. Again, riser should be placed at the thickest section of the casting, because the shrinkage is more to the thick section of the casting. That is very important. Shrinkage means concentrated contraction of the metal takes place at a particular location where the extra molten metal cannot be fed. That defect is called as a shrinkage. Next is lifts and shifts. You can see in the figure, cope has shifted to drag, means if we are not using the locating pins at a proper location, there will be shifting of cope and drag from each other, and the parting line will be shifted. External defect in the casting caused due to a misalignment of the pattern parts. While studying the types of patterns, we have seen in case of 2-piece or 3-piece patterns, we have to use the dowel pins. The dowel pins are used to keep the alignment between the two parts of the pattern. In the same manner, locating pins are used to keep the alignment between the two parts of the flask, that is scope and drag. Flask equipment or poor fitting of the mold jackets and improper handling of the molds. If the handling of the mold or the pattern is not proper during its ramming or pouring, then this lifts or shifts defect will come. Lift means cope and drag is lifted from each other, and shift means in a horizontal direction there is a shifting the location of cope and drag. That is lifts and shifts. It is related with the flask. Displace the core. Core has a shifted in the upward. In figure you can see the normal position of the core is at a center of that circular mold cavity, but it has shifted in the upward direction. That is displaced the core. Occur due to buoyancy of cores in the molten metal. Core should be firmly anchored. Buoyancy, I told you while studying the cores, the force exerted by the molten metal on the surface of core is called as a buoyancy. While studying that, I have given you the example of the force exerted by the water on the surface of the stone while you are sitting at the bank of the lake, and you are throwing the stones in the lake. At that time, that a stone has to jump for 3 to 4 times, then it is going deep into the water. The force exerted by that water on the surface of that stone is a buoyancy force. In the same manner, the force is acting on that core, and that core that force is responsible for shifting of that core. So that core should be firmly anchored by using metal pieces. In a long course, bending can be taken care by using the stiff irons and chaplets are placed correctly. The core should be supported properly by using a chaplet. If core has more length, more number of chaplets we have to use. We have to avoid a sagging of the core, bending of the core, or shifting of that core. Otherwise, displaced core defect will come and it has no remedy. Directly you have to treat this casting as a scrap. Poor shot. It refers to the condition of incomplete filling of the mold due to insufficient metal in the ladle and interruptions during pouring operation. Suppose that molder does not have any kind of judgment, means how much metal is present in the ladle and how many mold cavities are being filled up. He don't have any kind of judgment. At that time, poor shot defect will come. This is also major defect. It also has no any kind of remedies. So up to possible extent we have to avoid this defect. That is lack of molten metal inside the ladle, so incomplete filling of the mold cavity takes place. That defect is called as a poor shot. Next is metal penetration. This defect occurs if size of the sand particle is more. The metal plastically flows in between the two sand particles and damaging the surface of the casting. That defect is called as metal penetration. Penetration of metal in the interstices of the sand grains. It causes fused aggregate of metal and sand on the surface of casting, which results in a rough surface. This defect is also difficult to remove, this metal penetration, and it is affecting because of larger grain size of the sand particles. It is caused by the soft ramming. Again, these are the causes. If ramming of the molding sand is soft, this defect is liable to occur. Too coarse mold and core sand and excessive metal temperature. If temperature of the metal is more, absolutely its flowability will be more, and chances of that metal to flow into the two sand particles will be more, causing this defect, that is metal penetration. You can observe the appearance of the defect in the figure provided at the right side. Fins, a thin projection of metal which is not intended as a part of casting is called as a fins. This is also defect present on the surface of casting which is very easy to remove. Fins are generally occurring at the parting of mold and core section caused by runout of the metal. Metal flows out means along the parting line where cope and drags are joining. At that location, metal runout of the metal takes place. Poor fittings of the mold or the cores or high metal pressure. These are the few causes of this fins defect, and this defect is easy to remove, but it is occurring inside the casting process. Now we have seen various types of defects. Now we will see inspection procedure. There are various methods of inspection used in the industry for casting, forging as well as welding. First is visual examination. Visually the operator has to detect some defects which are present on the surface of casting. Visually you can detect surface porosity, cracks, again oxide scales, adhering sand, metal penetration. All these are the defects visually you can detect. But for visual examination we can also use the 10x magnification lens. This process can detect tiny cracks, pores or other surface discontinuities on a wide range of ferrous and non-ferrous metals. All those inspection procedure needs the skill. The operator has to qualify some few certification, then only he can go for the inspection. Next is sound test. The casting is suspended from a suitable support free of all obstructions and tapped at various places on its surface with a small hammer. Sound test is also very important. That test anybody can perform. Just we can perform that test in our home to check whether the marble which is fitted on the floor in our home has been supported properly from the bottom side or not. Means if that casting is having a big voids at its inside surface, then you will observe a different sound. And if casting is a solid, complete solid from inside, you will observe a different sound. And from that judgment of the two sounds you can easily say that whether this casting is made solid or it has a wide spaces. That is the sound test. Next one is the impact test. By using that test we have to calculate how much impact energy in terms of kilojoule that casting is going to absorb before its a failure under impact load. Means there are two different types of impact test we have seen, that is Charpy and IZOD. By using that test we have to take conclusion that whether that casting is suitable for the impact load or not. Next test is pressure test, also called as a proof pressure test. By using that test we have to check that whether the manufactured casting will withstand that much amount of pressure or not. That is called as a pressure test. That test is also used to find out whether that hollow casting is made leak proof or not. That is the pressure test. Next next test is radiographic test or X-ray examination. This test is suitable up to 60 mm thickness of the casting, forging or welding operation. If any kind of internal defects present inside the casting are found out by using the radiographic or X-ray examination. Again, skilled operator is required to perform this test as well as to analyze the films by used in the radiographic examination. Next is electrical conductivity test. In this method, current is passed through the casting. Read on the ammeter. If the casting has imperfections, there is a resistance to flow the current, and this is evident by drop in the reading. Means by using this electrical conductivity method, we can find out the normal cracks which are present just below the surface of the casting. That test is called as the electrical conductivity test. Next is metal penetrant inspection technique. This method is also used to find out the cracks which are present on the surface of casting by using dye and penetrant which are not visible to the naked eye. The cracks which are not visible to the naked eye are found out by using this penetrant inspection technique. Next is ultrasonic testing. This is used to find out the internal defects present inside the casting process from 60 mm thickness up to 200 mm thickness. Um, um, if there is any kind of big wide spaces present inside the casting can be found out by using this ultrasonic testing which are at more depth. Tests are also used to check the mechanical properties of that cast part like tensile test, bend test, notch bend test or hardness test. Means inspection procedure of that casting is consisting of some of the non-destructive test as well as destructive test. In this, whatever radiographic testing, electrical conductivity method, penetrant inspection, ultrasonic testing or dye penetrant, visual examination, all these are the non-destructive testing. Impact test, tensile test, bend test or hardness test means that test are destructive test. In the test, if we are providing any harm or destruction to the cast part, then it is called as a destructive test. And if during the test that casting is not harmed by any means, then it is called as a non-destructive testing. We will end here lecture. In the next lecture we will see the computer applications in the foundry industry.